Thank you for coming. It's a great public. I'm Jacinto Duran. I'll try to use this one first. My name is Jacinto Duran. I work for Red Tree Engineering, and we are a detail engineering firm that we work in the power industry and renewable energy, okay? Which is part of our bigger holding group, CSI Global. We have operations in the US, but also in Latin America, and we operate on a global basis with international customers. I'm the CEO of the company. I have a Bachelor of Science in Engineering and an MBA, and I have 23 years of all-around engineering experience, mostly from the construction side of the business, and 13 years working in EPC projects, where I got some experience quite a large experience on large EPC projects. I work for governmental agencies, global EPC players, startups, and international environments such as Latin America, Europe, Middle East, and the US. And as part of this experience in EPC projects, again, a lot of experience in first-of-a-kind projects that were scaled for the first time or had particular items that were executed at a commercial level for the first time and suffered the multiple challenges that you have. And basically, what I'm trying to do with this presentation is to show you at least a glimpse of some of the problems that happen, why they happen, and what can be done to avoid it. Okay? These are it's a sample of the projects I've been a part of, just to give you an idea of size and to get you a grasp of this. One is the Solana generating station that was built in Spain. It's actually 3 units, 50 megawatt thermal solar power, parabolic truck technology. It was the very first application for Abengoa in this project, and we built 3 of those units. The first one was a first of a kind, the other 2 were repetitions, and I think that the interesting part here is how from which unit to the next we really improved the process and reduced cost. And the second one was Solana generating station, was built here in the US, close to Phoenix, Arizona. It was a $1.6 billion power plant. I was a construction director there. And it was the very first application of thermal energy storage using molten salts. And it's probably still the largest ever done in the world. Okay? And we had plenty of issues building on that. The other one was a Jacinto, was built in the Negev desert in Israel. It was a thermal solar power plant, but also of the tower type, a different type. The plant included a 700 feet tall concrete tower and a 2,500 ton receiver that was built on the ground and lift to the final position in top of the tower. According to the company, to basically help us with the lift, it's probably one of the heaviest, highest lifts ever done. And we basically had to design for that and plan for that. It was completely first of a kind, it doesn't matter. And it was also first of a kind for GE Alstom at the time building this kind of plant. So it was double first time. And then Bellevue Solar is another different variation of thermal solar technology by GlassPoint. It's a company that was based here in California. It's operating right now in the Middle East. And basically, a different type of technology was the very first commercial deployment of the technology for the company. Each of these projects had a different challenges, but very common problems and very common solutions on this. So this is a challenge that you typically face when you have a first of a kind. Firstly, you're trying to implement a technology that is not mature, has been proven probably in the lab, maybe in a conceptual part, maybe in a pilot plant, maybe in a small scale plant, and you're trying to scale up to a commercial application. So engineering is still struggling to get plants developed, to get the final design, to understand what they need. And basically, they keep changing. Engineers are perfectionists. They want to get it perfect. You work on the front. They want to get perfect. And even after the design is done and you start constructing, you say, oh, by the way, we should change this pipe to stainless steel. And they send you the new drawings. And construction doesn't know what to react. And then basically, you get into this cycle. So this is one of the problems. The other thing is these projects are usually under pressure. The owners typically want to go online fast to go to the next step, and basically they're executing a faster approach, meaning you don't finish engineering before you start construction. Engineering is done as you build it. So that's another challenge. Usually in these applications, what happens is the R&D team and the business development team were overly optimistic on the cost. Everyone wants the project to happen, everyone wants the technology to go through, and when you get real costs in real life, in real world, costs are not what they were expected to be, so everyone gets surprised, and guess what? The project's already involved. The other thing that happens is the optimism and the lack of awareness on the project team on the changes. There's the lack of change control. It's a problem. It's a big problem in these projects. It's even larger than in a regular problem. So that's also a problem. And you have standard project managers, but then to execute properly this project, you need the next level. You need people to really go by the book and really have processes that allow you to avoid things to happen. So this is typically the challenge. So this is what I call the downward spiral. This is what goes wrong. So when things go wrong, engineers with all the good intention in the world and trying to get things right, they keep changing and they keep introducing changes to optimize the design, to ensure that things keep going the same way, or simply because something is missed because it's the first time they're doing it. When they're building a combined cycle like we did with Jason, there's not a lot of surprises. They know what they do, they know what is expected, they know what they have. When they're doing this for the first time, what happens is basically they don't really know what they don't know, and they're figuring out things on the go. So that's the very first thing that happens. They implement a change, they send the revised drawing to the purchase people, and they put in the supply chain. Usually you have long lead items, typical problems, pipe shoes, typical problem. No one thinks about them and they are long supplies. And these start to lag. Construction gets new drawings to build and they don't have the supplies, and the things start to generate defects, so one after another. Okay? Contractors issue change orders, the cost goes up, the schedule starts to slip, and basically suddenly your contract milestones with your contractor are not clear anymore and not enforceable anymore, which is even worse. Disputes arise, you ask them to accelerate, they say, okay, give me money, if not, I'm not accelerating, and things start to go worse. The project is under stress, the team and the project manager goes and just trying to be defensive, you're trying to stop penalty kicks instead of just really planning and looking ahead. And basically everyone starts to push, and in particular the owners, because they are the biggest ones, and the more affected ones, because of the liquidity damages or the cost of the finance and everything goes, or prior commitments start to kick. And then everything goes down from there. Okay? At the end of the day, if it's not stopped, everyone loses. The owner loses, the contractor loses, the subcontractor loses, everyone. Everyone is in play. So this is about getting the right approach to avoid this to happen. Okay? So the thing here is highlighting the importance of implementing the processes to mitigate the issues and protect the stakeholders. One thing we did really well at GE and also is implementing steering committees that we're meeting frequently, that we're having a very honest and detailed review of the status of the project on a monthly basis. So you get all the stakeholders on the table and you make decisions collectively. This requires transparency, but this is the right way to do it. The second one is to ensure that previously to financial investment decision, basically prior to making the decision, the teams have the understanding of the real status of engineering. And what happens in general is usually companies are pushing R&D departments to launch the new technology as soon as possible. There's pressure on that. There's typically pressures on reducing costs by a certain percentage. And if the status of that design is not properly done, basically what typically happens is bad decisions are made, you launch a project to be built before it's actually ready, and this then generates the fire. So it needs to be very, very, very detailed. Change control and managing both risks and opportunities. Opportunities are always there, cannot be forgotten, but also putting an emphasis on change control, both on and deciding if an engineering change is really needed or not, or if it's a nice to have, but also understanding other changes and basically making individual decisions on each one on a committee approach within the project, understanding all the impacts of a change before a decision is made to go for it. And the other one is integrating the schedule and the cost management and using the right KPIs. Cost and schedule are tied. Reducing schedule always costs more money, and making changes always costs more money. So this needs to be controlled and measured with the right KPIs to keep that. The risk management approach and managing the contingency in a controlled and uniform way. One thing we implemented really well in the last few projects is having a very detailed list of risk with a cost associated, with a probability associated, with a mitigation to that risk associated, and managing that and tie that to the contingency pool and understanding how much of that contingency that we have left in the project was actually available and how much was committed or used or to be used. So that allows you to know how much you have executed of the project, how much is your contingency left, and you start to see a lot earlier if the project is about to fall in a financial problem. And that would be the right way to do it. It's not usually done that way. Usually contingency is a bag where people pull from the bag until someone puts the bag, the hand in, and there's no more money. And that's when problems happen, and there's no warning on it. So proper management here is very, very important for jumping ahead and resolving the problems ahead of time. And I guess the other problem, there's two more, which is professional contract management. When changes happen, I mentioned before, the contractors, everything becomes messy. The contractors and the key milestones are not enforceable anymore. So reaching an early agreement, even if you need to pay money, it's a lot better than not reaching any agreement and get to the end without clarity and not being able to enforce milestones. That's a very important lesson learned. And basically having everything in written, agreeing, solving the problem, writing an amendment to the contract, moving on. If not done properly, basically things get worse. And finally, the role of the owner and the owner's representative is key. A positive owner can make a project succeed. A bad owner can make a project fail, just with the same team. And I'm saying this with probably one of the best owner representatives I ever had, Mr. Jacinto. It's very positive, and it was probably my best experience ever there. So summarizing this, and basically the understanding that in a first-of-a-kind project, change is the only certain thing. The only thing we know at the beginning is that we're going to have change. We need to manage it properly. Avoiding being overly optimistic and having the right levels of contingency is also absolutely critical. It would be lying to ourselves. And linking the contingency with the risk management is also a must. Otherwise, we're risking getting to mid-project and running out of contingency and having not having the sources to complete the project. Actively engaging all the stakeholders. The project manager is key, obviously, but the steering committee has a key role in making the right decisions and keeping everyone informed. That's a very, very important governance piece of the governance of the project. And enforcing the design freeze process with engineering is absolutely key. And once it goes to construction, there needs to be an extremely good reason to make a change. Otherwise, it cannot be allowed. Okay? And establishing a project management committee to make decisions to evaluate changes when it's needed. If the design freeze needs to be altered or broken, well, there needs to be a very good study about the impacts, and the decision needs to be made with all the impacts on the table. And finally, just professional contract management, schedule and cost control is key to produce information and the KPIs and the information needed for the steering committee to make the best decisions and the right decisions is absolutely necessary. I mean, with these elements, that it would take probably hours and hours to discuss. I mean, you can definitely mitigate and control the project with a minimal amount of risk, or at least minimizing the impacts of changes. Okay. And that would be basically the end of it. Having questions? So. Thank you. Okay.
The question, I guess.
Yeah. It's very difficult already. So that's what makes a difference. I mean, people will go and say, okay, I will put 10% contingency and just put that as a regular number. That could be a little bit tricky. I mean, it feels great in the FID phase, or you're making the investment decision, or we're trying to get the funding. But actually, in order to define your contingency, first you need to know what is the status of your engineering. It's not the same to go into an EPC phase and sign an EPC with a 10% engineering, or with absolute basic engineering, than with 30% engineering, than with 100% engineering. Your uncertainty level is completely different. So, and having a contingency level that is in line with your level of engineering when you define and when you launch the project is key. So you need to tie both things. That's one. And the second thing is going into the details. In my experience, usually when I receive a project as a project director, what I would receive is, well, here's your contingency. You just get a number, and you don't get much more. So if that's the case, and you're receiving it, what I did and what I learned to do is you list all your risks, you basically calculate what will be the impact in cost of each of those risks, what is the probability, and you get your weighted average, and you basically calculate your expected cost on that. And then you manage. And usually, if the contingency is properly set, hopefully, what happens is, well, you have extra money in the contingency. Well, I'm using 50% of the contingency with the risk. Then through the project, you work on mitigating or removing those risks. And each time you do, you remove it from there. But on a monthly basis, you keep control of that. And new things will come to happen, and you need to manage that. So one practice I found that is very good to manage the contingency through the data of the project is you have your earned value of the project and how much you have progress, and you can graph that along with the contingency used. And when you put those graphs together and you start to align them, you will see what is your trend. Are we burning more contingency than we're actually making progress? What is expected part looking forward? And when you start putting those things together and producing the right KPIs and the right analysis, the steering committee is going to be able to look at it together and see, well, we're in the right trend or not, and you will get early warnings. The early warnings are very important because if you let all the stakeholders know that there's a problem months before it explodes, well, someone can do something about it. If you just let them know the moment it exploded, nothing can be done about it. So it's also about, sometimes change is unavoidable, but the earlier you know, the better, and the better you are going to react. So this is all about that. Everyone understands it's going to be changes. How you manage.
Could you give some examples of good KPIs versus bad KPIs?
Good question. It will depend on which element you're working. When it comes to scale, for example, and cost control, SPI and CPI, that are basically the digital KPIs that you follow for schedule performance index, which is basically how much progress you made versus how much you should have made. That's a good one. This one's basic one. And the cost performance index, which is the same, but with cost. How much cost I have spent versus what I should have spent with this progress. So that will give you a trend. Measuring your cost to complete properly is important. I mean, when you talk to people or when first measure that I'm professional, people will take, well, what is your incorrect cost? It's X. The cost to complete is the budget that costs minus X. Well, that's not the cost to complete, clearly. The cost to complete, you need to make a real effort to calculate what is really pending. And there's methods in I don't know, PMP or from a PMI book that suggest that. Those are good. Those methods can be more complex if you have the tools and the resources in a larger project to do it. But obviously, you need to use methods that are and KPIs that are, can be measured consistently with the resources you have. If you're in a project that is very small, you cannot have two controllers and 3 planners, and it's hard to do it. So you need to scale your controls and your KPIs into something you can manage with the resources you have. If you are in a $1.6 billion project, you probably have 3 planners and 3 controllers. So you're probably going to be able to have more numbers. So you need to balance and choose the right KPIs for the size of the project. It's kind of you need to calibrate for the size of the project and the resources you have aligned. Jason,
You want to go next? Or?
Yeah.
Yeah, sure.
Thank you. Oh, thank you. Thanks, everyone.